Hi, my name is Marc Lamberti. I'm the head of customer training at Astronomer and I'm super excited to be with you today. In this video, we are going to discover what are XComs and why you might need to use them in your data pipelines. Indeed, one of the first questions you will have is how can I share data between tasks in a data pipeline? Well, that's exactly what XComs allow you to do. So we are going to discover what is an XCom specifically, how can we create an XCom and how can we fetch that XCom from another task. We are going to discover different ways of pushing and pulling XComs in Apache Airflow, and more importantly, we are going to see the limitations of XComs and why sometimes you can end up with troubles if you don't know what you are doing with them. So without further waiting, let's get started. In order to explain the XComs, we are going to start with a very simple use case. Let's imagine that you have the following data pipeline with only two tasks. In the first task, training machine learning models, you train machine learning models, and for each machine learning model, we have an identifier. This identifier allows us to know which machine learning model produces which output. Then, in storing machine learning model results, what we want is to store the results of the machine learning models along with their identifiers. The problem is, the identifiers are automatically generated in the first task. So how can we share those identifiers in the second task storing machine learning model results? Well, there are two ways to do that. The first way is to use an external tool. You can think of a database or AWS S3 for example, and so in the first task, you will store the identifiers in that external tool, in that database for example, and then in the second task, you will fetch the values from that external tool. This way is truly useful if you have gigabytes or terabytes of data. For example, you might have a task fetching data from an API and then this data you want to process it with Spark. What you will do is to put those data, if you have gigabytes of data, in an external tool, and then in the second task to process your data with Spark, you will launch a Spark job that will fetch the data from the database. By doing this, you avoid getting memory overflow errors because you are trying to share too much data in your Airflow instance. Now, what about if you have a small amount of data? Well, in that case, you can use XComs. XCom allow you to share data between your tasks only if you have a small amount of data, and we are going to see what does that means. But basically what you will do is to create an XCom from the task training machine learning models by pushing it, so you will push an XCom in the database in the metastore of Airflow, and then from the second task, storing machine learning model results, in our case, you are going to pull that XCom using a special function that we are going to see in a minute. And that's how it works in Airflow. One thing to remember here is that we are using the metastore of Airflow, whereas in the first way, we were using an external tool like a database. Just to sum up, XCom stands for cross-communication, and XComs allow you to share data between your tasks in your data pipelines. Now we have seen what are XComs, let's discover how to use them in practice. At this point, the video is going to be really hands-on focused, and I strongly advise you to follow exactly what I'm going to do on your computer. Also, all the materials that I'm going to use are available in the description below. Now, in order to set up and run Airflow on my computer, I'm going to use the Astronomer CLI. If you don't know what is the Astronomer CLI, it is an open source command line interface developed by Astronomer in order to set up and run Airflow in the easiest possible way on your computer. Feel free to check the documentation in order to know how to install it on your operating system. It is pretty easy to do it. Alright, once you have installed the Astronomer CLI, we can move on. In your terminal, create a folder, Astro, for example. Let's do this, Astro, and go into that folder. This folder will contain all the files and folders automatically generated by the Astronomer CLI in order to set up and run Airflow. To do this, type astro dev init. With that command, we initialize the development environment, and now if you type ls, as you can see, we have some files and folders corresponding to Airflow. Next, open the folder with your code editor. From there, open the folder dags, and create a new file xcom_dag.py. Then, from the materials, under the section static code, copy the following code corresponding to the data pipeline, and paste it in the file. this data pipeline is pretty simple. Indeed, we only have two tasks, training_models and storing_models, both using the Python operator in order to execute a Python function. For training_models, we execute the function _training_models. That's what you can see here. And for storing_models, we execute the Python function _storing_models as shown right there. Before diving into the XComs, let's update the Airflow version that we use with the Astronomer CLI. To do this, go back to the materials and copy the following line right there. Then back to your code editor, open the file Docker file corresponding to the Docker image of Airflow that we are going to use and paste it like that. Save the file, then in the terminal type astro dstart in order to set up and run Airflow on your computer using Docker. Enter. As you can see, all the components of Airflow, the Metastore, the scheduler, and the web server are running. Now if you go to your web browser and open a new tab, then go to localhost :8080, you should land on the user interface as shown right there. If you click on XCom_DAG, then grab view, as you can see, we obtained the data pipeline. Now what we want to do is to share the machine learning model identifiers generated by training_models with the task storing_models. Let's discover how to do that with XComs. Back to your code editor, each time you want to interact with XComs in Airflow, you need to access a task instance object. And a task instance object corresponds to a task, for example training_models, executed in a DAGRun. In order to access the task instance object with the Python operator, you need to provide an argument which is provide_context equals to true. With that argument, you will be able to access the context of the current DAGRun in the Python function training_models. So in the function, here type ** context, and then you are able to access the context of the DAGRun. I strongly advise you to print that context in order to know all the attributes that you can access from it. Next, we define some machine learning model identifiers, ml_IDs, equals to a list, ml_1, ml_2, and ml_3. So we want to share this list, those identifiers, with the task storing_models. How to do this? We create an XCom. Here, type context ti in order to access the task instance object corresponding to the running task training_model. Dot XCom_push to push an XCom. XCom_push expects two arguments which are key and value. For the key, we specify ml_IDs, and for the value, we specify the MLIDs. The key here is extremely important because it will be used in order to pull that XCom from the other task. Save the file and let's verify if that works. To do this, in your terminal, type astro dps and then docker exec -it, the scheduler, /bin/bash in order to open a bash session in the container scheduler. From there, we can execute Airflow commands, and the command we are going to use is Airflow test in order to test a given task. So here you type Airflow test XCom_DAG, the task that you want to test, which is training_models, and an execution date in the past. Let's put 2020-01-01. Enter. Let's wait a little bit. And as you can see, the task succeeded. Next, if you open the Airflow UI and go to admin, XComs, as you can see, an XCom has been created as expected with the key ml_IDs, this is the key that we have specified, and the value corresponding to the list of machine learning model identifiers. In addition to the key and the value, we have the timestamp to know when it was created, we have the execution date corresponding to the execution date of the DAGRun when that XCom has been generated, and we have the DAG ID and the task ID so that we know that this XCom has been pushed from the DAG XCom_DAG in the task training_models. One thing you have to remember is that by default, Airflow looks for XCom that are created in the current execution date and DAGRun. That means if you have multiple DAGRuns pushing and pulling XComs, you will never end up with XCom pushed from a DAGRun and pulled from another DAGRun. By default, all XComs are isolated with their current DAGRun. By the way, if you create a new XCom with the same execution date and key, as you will see, that XCom will be replaced by the newest XCom. If you go back to your terminal and execute the task training_models again, as you can see, back to the user interface, if you refresh the page, pay attention to the timestamp, you end up with a new XCom as we have kept the key and the execution date. Alright, now we have pushed an XCom from the task training_models. Let's discover how to pull that XCom from the task storing_models. Back to your code editor. In the task storing_models, we need to provide the context as well. So provide _context equals to true. And then for the Python function storing_models, we put the context as we need to access the task instance object to execute the function XCom_pull. So type context square brackets ti dot XCom_pull in order to fetch the XCom that we have created in the function training_model right there. Then in that function, we have to pass the task ID where the XCom has been generated. So task IDs equals to training_models, and that task ID, that value here corresponds to the task ID that we have defined for the task training_models, and the key of the XCom, which is ml_IDs. Like that. Let's create a new variable, ml_IDs, and print that variable in the output, ml_IDs. Save the file and let's verify if it works. In your terminal, execute the same command that we used for training_models, but this time with storing_models. Like that. And make sure that you are using the same execution date, as Airflow will use that execution date to know the DAGRun where to fetch the XCom. Enter. And as you can see, right there, we obtained the list of machine learning model identifiers as expected. So at this point, we're able to share data between two tasks using XComs, where in the first task, we use XCom_push in order to push the XCom in the metastore of Airflow. And then in the next task, storing_models, we pull that XCom from the metastore of Airflow using the key ml_IDs and the task ID training_models. One thing that you have to know is that in XCom_pull, you can add two more arguments. The first one is DAG_ID, and this one allows you to pull an XCom coming from another DAG. I strongly do not recommend to do that, as you will create some dependencies deeply hidden between different DAGs, as you won't be able to see those dependencies in the user interface. Then another argument is include_prior_dates. And this argument allows you to pull XComs coming from past DAGRuns. Again, you have to be careful with that because you will create dependencies between DAGRuns. But let's discover how that argument works. If we set the argument include_prior_dates to true, we should be able to pull all XComs that have been generated for a given DAG across all DAGRuns. Let's verify this, save the file. Then in the terminal, let's create a new XCom, this time with another execution date. Let's put 2 here, enter. And if you go back to the Airflow user interface and refresh the page, as you can see, we have a new XCom with a new execution date. As we use include_prior_dates in the task storing_models, we should be able to pull those XComs from it. Go back to your code editor, and in the terminal, execute the task storing_models, but this time with the execution date, the 2nd of January 2020, as we want to get the XCom corresponding to that execution date, but also the previous ones, the one that we have created for the 1st of January 2020, as shown right there. So back to the code, execute the command, and as you can see, we get only one XCom as shown right there. Why? Because by default, XCom_pull returns the latest XCom for a given key, task ID, and DAG ID. So here we are pulling the XCom corresponding to the execution date, the 2nd of January 2020. So the question is, how can we pull multiple XComs at the same time? Let's discover this right now. In order to pull multiple XComs at the same time, we are going to use a function get_many. Since get_many is not available within the task instance object, we need to import the class XCom. Let's do this right now. At the top of the file, type from airflow.models import XCom. Then, in the function storing_models, let's create the same variable ml_IDs equals to xcom.get_many, and then we need to specify some arguments. The first argument is the execution date, like that, corresponding to the execution date of the current DAGRun. To do this, use context with the key execution_date. Next, we need to give the DAG ID where the XComs will be pulled from. So type DAG IDs equals to context, again, dag.dagID, like that. And finally, we need to pass the argument include_prior_dates as well equals to true. Let's print ml_IDs, print ml_IDs, save the file, and in the terminal, execute the command airflow test xcom_dag storing_models with the execution date defined to the 2nd of January 2020. Enter. And if we wait a little bit, as you can see right there, we obtain a list of XComs as expected. If you take a look at the execution dates, we have the 2nd of January 2020 and we have the 1st of January 2020. Notice that it wasn't the case with XCom_pool and include_prior_dates, as we got only that list corresponding to the latest XComs with the execution date the 2nd of January 2020. Alright, now we have discovered how to pull multiple XComs at the same time. Let's discover how to pull XComs from different tasks. You might have noticed that XCom_pool has an argument task_IDs with this little s right there. This indicates that you can specify multiple task instances, and so you can pull multiple XComs coming from different task instances as long as those XComs have the same key. For example, let's imagine that you have the following data pipeline with 3 tasks that are going to be executed in parallel. Each task pushes an XCom with the key ml as shown here. And so one thing you might want to do is to, in the next task, this one, execute the function XCom_pool with the key ml in order to get all XComs that have been generated by all the previous tasks, those one. So let's discover how to do this. Back to the data pipeline, remove that part, get_many, and include_prior_dates from XCom_pool. Then in the materials, copy that task, processing_models, which uses a Python operator, paste it there, like that. And we need to import processing_models as well. So back to the materials, copy the Python function, _processing_models, and paste it here. So this function will be executed by the task processing_models right there, as we do with the other tasks training_models and storing_models. Now if you go back to the Python function here, as you can see, we create a new XCom with XCom_push with the same key ml_IDs, but this time with the following value ml_1_processed and ml_2_processed. Now, in order to fetch both XComs from processing_models and training_models, in storing_models, and more specifically in XCom_pool, here for the task IDs, we put a list of task IDs with training_models and processing_models, like that. Save the file, then in the terminal execute the command processing_models in order to create the new XCom with the same execution date, the 2nd of January 2020. Let's wait a little bit. Perfect. If you go back to the user interface of Airflow and refresh the XComs view, as you can see, we have a new XCom corresponding to the task processing_models. Back to the code. If you execute Airflow test storing_models and wait a little bit, As you can see, this time we pulled two XComs that have been generated by training_models and processing_models. That's how you can pull multiple XComs from different tasks. Alright, so far we have learned how to push an XCom using the function XCom_push. One thing I would like to show you is how to do it with the return keyword. Let's discover this right now. One thing you have to know is that instead of using XCom_push, you can create an XCom with the return keyword. To do this, pretty simple, you just need to remove that line, for example, and here type return, then the value that you want to push in an XCom, ml_processed_IDs in our case. Then in storing_models, in order to fetch that XCom, you just need to pass the task ID where the XCom is created, and you can remove the key. Why? Because by default, this XCom that will be created automatically with return will have the key return_value. And so in XCom_pull, if you don't specify a key, by default, Airflow will look for an XCom with the key return_value. Let's verify this right now. Save the file. Then here, execute the task processing_models. Let's wait a little bit. Perfect. Now, if you refresh the XComs view, as you can see right there, the XCom has the key return_value. Back to the terminal. If we execute the command storing_models, as you can see right there, we obtain the XCom that has been automatically pushed for us with the return keyword as expected. Keep in mind that in general, anything returned in an operator will be pushed as an XCom in the metastore of Airflow. Alright, so we have seen another way to push an XCom. Now let's discover another way to pull an XCom using templating. I won't explain what templating is, but you have to know that you can pull XComs in templates. To show you this, we are going to modify the task storing_models. In the Python operator, you can remove provide_context and specify a new argument op_keywords equals to a dictionary. If you don't know what op_keywords is, well, this argument allows you to pass parameters that you will be able to use in the Python function. So in our case, anything that we put in op_keywords will be available in the Python function storing_models. Also, keep in mind that this argument is templated, and that means we are able to inject data at runtime by using that argument. Let's create a key, ml_IDs, equals to 2 pairs of square brackets to indicate that we want to inject data at runtime at this specific location. Then ti for task instance, XCom_pull, then we specify the task ID equals to processing_model. Like that. Next, in the function storing_models, we can remove the XCom pull as we do it in a template, and we remove context to put op_keywords like that. Then we print op_keywords and more specifically the key ml_IDs. Save the file and we are ready to check if everything works. Before doing this, actually I just made a typo right there, so you have to put a S for processing_models, then save the file, and in the terminal, execute the command airflow test with storing_models. Enter. Then if we wait a little bit, as you can see right there, we obtain the XCom that has been pushed by the task processing_models by using XCom_pull from the task storing_models in a template as expected. Alright, now you have discovered how to pull an XCom in a template. I would like to show you how to push an XCom with another operator, which is the BashOperator. Let's discover this right now. Some operators either push XComs automatically by returning a value, like the S3 list operator, or you have to enable an argument XCom_push in order to push an XCom, and that's exactly the case with the BashOperator. Since this operator is widely used, I would like to show you how to do it. First, we need to import the BashOperator. So here, type from airflow.operators.bash_operator, import BashOperator. Then, after storing_models, create a new task deploying underscore models equals to the bash operator. We specify a task ID equals to deploying underscore models. Then we have to define the bash command that we want to execute. Bash underscore command equals to echo deployment done for DAGRun, then 2 pairs of square brackets, DS, corresponding to the execution date. One command thing we want to do with the bash operator is to get the output of the executed bash command. And to do this, you can pass the argument XCom underscore push equals to true, so that the output of that command will be pushed as an XCom, and you will be able to pull the XCom from another task if you want. So save the file, then in the terminal, execute the command airflow test with deploying underscore models. Enter. Let's wait a little bit. Perfect. If you go back to the user interface of Airflow and refresh the view, as we can see right there, we obtain a new XCom with the key return underscore value and the value corresponding to the command that we have executed in the bash operator. Remember that with the bash operator, you won't be able to specify the key, and so that's why each time you push an XCom, that XCom will have the key return underscore value. Finally, some operators do not return any XCom at all. And so if you want to modify this behavior, you will have to overwrite the given operator. Alright, that's it for the hands-on part. I hope you enjoyed it. Now let's discover the limitations of XComs. So far in the video, we have discovered how powerful XComs are, as we are able to share data between tasks, but you absolutely need to know the limitations of XComs, otherwise you will end up with many troubles. And the first limitation that you absolutely need to be aware of is the XComs are limited in size. Indeed, depending on the database you use, either SQLite, Postgres or MySQL, you won't be able to store the same amount of data in your XCom. With SQLite, the value is limited to 2 GB, with Postgres 1 GB, and with MySQL 64 KB. So you absolutely need to be careful with the value that you put in your XCom, otherwise you will end up with a memory overflow error. Next, the problem with XComs is that it is easier to have the tendency of taking Airflow as a data processing framework, which is not. Again, Airflow is an orchestrator. If you want to process gigabytes or terabytes of data, you should use Spark with all the optimizations that it brings. Okay, don't try to use Airflow in order to process gigabytes or terabytes of data. You will end up with memory overflow errors, and that's not the job of Airflow. Finally, and this one is truly important, XComs create implicit dependencies in your tasks that you are not able to see from the user interface of Airflow. Indeed, as soon as a task needs an XCom coming from another task, you create a dependency between those two tasks. And so if for any reason the first task is not able to push the XCom, the second task will end up in failure. So you absolutely need to be careful with that. You create hidden dependencies as soon as you start using XComs in your tasks. So that's it about XComs. I really hope you enjoyed the video. I really hope you have learned a lot about XComs. Obviously, there are other features with XComs that we have not seen in this video, but if you want to learn more about XComs, well, feel free to reach me. I will be glad to help you. Have a good day, take care, and see you in the next video.